Okay. Now, in our last lesson, we learned about the equation of tangent and equation of normal. So the three things that we need to know is how to find the equation of a straight line. In order to find the equation of a straight line, you must know the gradient m and a point x1, y1 on the curve. Okay, so knowing these two things, you can find the equation of the straight line. Next, you must also know dy dx means the gradient of tangent at a particular point on the curve. But of course, if it's given in x, then it is a function. It's a gradient function. Right? Unless you substitute in specific numbers for x, then you will get specific gradient. Okay, so the last thing you need to know is m1 m2 is -1. If m1 is the gradient of tangent, m2 is the gradient of normal, then the product of m1 and m2 is -1. But we seldom use the equation in this form. Normally we use this form, the red color. That is, the equation of tangent is the reciprocal of the gradient of tangent, and you have to change the sign. If it's positive, you change negative. Negative, you change to positive. Right? Well, I have shown you four examples that need to find the equation of tangent or equation of normal. But normally, the more difficult questions in the exam, they are like this. So these questions, they involve unknown. In the original equation of the curve, there's unknown there. So we look at question number 46. So where is question 46? Yeah, it's over here. We look at question 46. Now, in question 46, the gradient of normal to the curve y equals to x plus a square plus b at the point 110 is -1/8. Find the values of a and b. Now you are let me go through the question again. What you are given? You are given first the equation of the curve, a point, and the gradient. That is gradient of normal, right? Gradient of normal. Okay, right. Okay, so you are given these three things, and there are two unknowns in the equation of the curve. Now, normally from our knowledge of simultaneous equation, if you have two unknowns, then you need to have two equations. So in this case, you have to form two equations. So how to form two equations from the point and from the gradient of normal, right? So you have to find the two unknowns a and b by forming two equations. Okay, so let me go through on this side, right? On this side. So you look at the question 46, the question y equals to x plus a square plus b passes through the point 110. Yeah, correct, it's 110. So it means that the coordinates means two lah, the x coordinate and the y coordinate. The coordinates of this point must satisfy the equation of the curve. Okay, so you must know that. So the first thing is you take the point, you substitute into the equation. The x coordinate you substitute into the x, and the y coordinate you substitute into the y. Okay, now so far any question? Okay, any question? So I continue. All right, so because this point lies on the curve, the coordinates of this point must satisfy the equation of the curve. In other words, I can take the coordinates of this point and substitute into the equation of the curve. It is perfectly all right. It is valid. Okay, you can do like that, right? So when you substitute in, then you get one equation. Tan equals to 1 plus a square plus b, and you leave this equation aside. Leave it aside. Okay, next, the gradient of tangent, but given here is gradient of normal. So I cannot find the equation of normal, the gradient of normal straight away. I have to find the gradient of tangent at the point 110. Now, how to find the gradient of tangent? Okay, differentiate the y. Differentiate the y, you bring the 2 in front, right? Then less by 1, then there's a 1 there. Then differentiate b, because b is a constant. When you differentiate b, it becomes 0. So in the gradient function, and this is the gradient function, that means the dy dx in terms of x. In the gradient function, you can no longer see the b there. Differentiate becomes 0. Then because we want to find the gradient of tangent at the point 110, you can substitute the 1 inside the gradient function. You can substitute the 1 inside. And this, I call it m1. m1 is the gradient of tangent. Now, if you want to find the gradient of normal, can you still remember? You need to reciprocate the number and change the sign. Okay, reciprocate the number. Okay, here I reciprocate or inverse lah, terbalik, inverse the thing. And I change from negative sign to positive sign. Now, after undergoing this process of inverse the number and changing the sign, this thing is no longer the gradient of tangent. It is the gradient of normal. Today I've forgotten to ask you, can you hear me or not? Can you see the screen?
Yes,
What?
teacher.
Can,
Can.
can hear and can see the screen. Okay.
Yeah.
Otherwise, I keep on talking to myself and don't know what is happening. Okay, right. So we take the equation, the number which represent the gradient of tangent, reciprocate it, that means inverse it, terbalik, then change the sign, it becomes the gradient of normal. So this gradient of normal is given to me negative 1/8. So on this side, the m2 I replace with negative 1/8. Okay, I have to solve this equation. How to solve? Terbalik the 2, then change negative become positive, right? So we have this equals to 4, then a equals to 3. Okay, so finally you get a equals to 3. So this is the value of a, and you can substitute this value of a back into the equation here. 3, substitute 3 here, become 16. Become 3 plus 1 become 4. 4 becomes 16. 16 bring over the other side, become negative 6. Okay, now so far understand or not first? Understand that?
Teacher,
Yes.
teacher, for the gradient of the normal at 1 and 10, you write m2 equal to negative 1 over 2, blah, blah. It's because the gradient of tan is equal to gradient of normal.
Gradient of tangent is not equals to the gradient of normal. Gradient of normal is negative 1 over gradient of tangent. Negative 1 over that gradient of tangent. Okay, so back here, so this is the gradient of tangent. I put a negative, then I put 1 over the gradient of tangent. Then it becomes the gradient of normal. Okay or not?
Okay, teacher.
Okay. So far, any other question? No. No, then I go through again how to tackle this type of question. You're always given a point. Point you cannot substitute into gradient. Point you substitute into the curve. It will give you one equation. Okay, that is the first thing. Then the second thing is you have to find dy dx. The dy dx, you change it to, you substitute number inside dy dx. Now we equate this dy dx with the gradient of tangent, or you equate the dy dx with the gradient of normal, but you have to change it like in this way. So relating the gradient and relating the point, you will get two equations, and you can solve for any two unknowns in the equation of the curve. Okay, now so this is what we're going to do. Okay, so we look at question number 53. Our question 53 is like this. Given that the tangent to the curve at the point AB is parallel to the line, find the values of A and B. Alamak, find the values of A and B pula. Okay, now the unknown is not inside the equation. It's not inside the equation of the curve. The unknown is the point, right? And you have to find the values of A and B. You are going to relate it this way also. The point you substitute inside the equation of the curve, find the equation of find the gradient of tangent, equate it with the gradient of tangent, something like that. So we look at how to do this question. Okay, right. Okay, ready or not? Okay. Now the equation of tangent is the equation of the curve is y equals to 3x squared minus 12. Okay. Now this question is about dy dx. So whenever you see the equation of the curve, you find dy dx. Whether you can get the answer later on or not, if you can find dy dx, you can get 1 mark, because that is required by the question, right? So if it's required and you can find dy dx, you can get 1 mark. Don't just give up, don't try. You have to try. Now to give you the confidence, you try now lah. So in the actual exam, you even if you don't know the question also, you just write out whatever you know, gradient, dy dx, substitute in point, substitute this, substitute, you will get some marks, right? Okay, so this question about dy dx, so I find dy dx. Very simple. Dy dx is just 6x. Differentiate, you get 6x. Differentiate 12, you get 0. So I keep this equation of gradient function. The gradient function or the dy dx I keep. Now I look at the question again, right? They say tangent to the curve is parallel to this line. I copy this line. Y equal to 6x. Minus 6x plus 4 equals 0. I copy this equation, right? Then I try to find the gradient of this line. I change this equation to the form y equals to mx plus c. This one involves the knowledge of coordinate geometry that you have learned last year. So the given line, I change to y equals to mx plus c. The reason is I want to get the m. Y equals to mx plus c. So I want to get the m here. The m is 6. That means the equation of this line is 6. Okay, the equation of this line is 6. Then they tell me parallel. The tangent is parallel to this line. Tangent parallel to this line. So that means the gradient of tangent here must be equal to the gradient of this line. Okay, now? So the gradient of tangent here must be equal to the gradient of this line. That's why they are parallel, right? Parallel lines, the gradient are the same. So when I equate this 6x with the gradient of the line, I get x equals to 1. X equals to 1 is the x coordinate of the point. So it means that a equals to 1. It means a equals to 1. If x equals to 1 means a equals to 1 because a is the x coordinate of the point. There they say the point is AB. So a x coordinate, right? Oh, I know x equals to 1. I substitute back into the original equation here, equation 1. Why I cannot substitute into equation 2? No. Because the point the point doesn't lie on this line. The point lie on the curve. Okay? The point, the gradient at that point is parallel to this line. It means that the point doesn't lie on this line. Only that gradient is the same. The point is not there. Okay, so where is the point? The point is on the curve. So I substitute the x equals to 1 back into the curve number 1 here. Curve number 1 here. So substitute back, I get y equals to negative 8. If y equals to negative 8, it means that the value of b is negative 8 because b is the y coordinate of the point. Any question?
No, teacher.
No question. This one looks very difficult, but the solution is simple. So this is the application of equation of tangent and equation of normal from these old questions here, from these old questions. Okay, so we're going to look at some newer questions from your textbook. Okay, so we're going to look at some newer questions from your textbook. So no, I go to the next page. Now these are the questions from your textbook. I'm going to show you two examples from exercise 2.9. So I'm going to show you example using question number 3 and question number 5. So the others, number 1, number 2, and number 4, you do it yourself. Again, these questions you need to know, you need to have some basic knowledge of coordinate geometry that you have learned in form 4, because these are about curves. They are about curves and points on the Cartesian plane. So if that is the case, surely they will involve the coordinate geometry that you have learned, whether about parallel lines, perpendicular lines, gradient of the lines, and so on. You make use of it. Okay, so I go on to question number 3. Question number 3. Wait, I see what is next. Question number 5, right? Question number 5, correct. So now we do question number 3. Okay, I read question number 3. In the diagram on the right, the tangent to the curve y equals to ax cubed minus 4x plus b at point P 2, 1 intersect the x-axis at Q 1.5, 0. Normal at P intersect the x-axis at R. Find the values of A and B. Wow. Okay, right. One more time. Let me see what they're talking about. Tangent to the curve at the point P. So that means there is a tangent. The tangent is the blue line there. The tangent to the curve is at this point P 2, 1, right? Intersect the x-axis. Intersect the x-axis at Q. Okay. The normal to the P intersect at R. The normal at P, we don't think about this normal at P first. So you just concentrate on the tangent at the point P, right? So it doesn't involve so many things lah. So if you think of tangent, you think of normal, then kelam kabut already. So what you need to do is you think about the curve and the tangent. So the tangent passes through the point 2, 1. Now what did I say just now? If it passes through 2, 1, this 2, 1, what can you do with the 2, 1?
Substitute the
Yes,
coordinate into.
correct, correct. So this is the equation of the curve, and it has two unknowns there. So I try to form two equations to solve for the two unknowns. So the first equation that I'm going to form is by substituting the coordinates of the point P into the equation of the curve. Okay, so what did I write here? Y equals to ax cubed minus 4x plus b. Since the point 2, 1 lies on the curve, the coordinate must satisfy the equation. So I substitute 2 inside the x, substitute 2 inside the x. Then the 1 I substitute inside the y. 1 I substitute in the y. Then you try to simplify this equation, and you have a plus b equals to 9. So that is the equation of the first equation I formed. Now another thing is about the tangent, right? Now we cannot relate directly with the equation of tangent. We can only relate with the gradient of tangent, right? So try to find the gradient first. How to find the gradient? I find dy dx, right? dy dx. So how to find dy dx? Differentiate. Differentiate this become 3x squared. Differentiate negative 4x becomes negative 4. Differentiate b becomes 0, so no more b. Then this one is the gradient function. You need to substitute in values for x. So I look back here, the x that has tangent is 2, right? The value of x is 2. So I substitute the value of x equal to 2 into this equation, then I will get the gradient of tangent at this point here, right? But before doing it, before substituting the point 2 inside, I try to find the gradient of PQ, because both P and Q, the coordinates of both P and Q, they are known. So if the P and Q are known, then I can find the gradient of PQ. So here I proceed to find the gradient of PQ. Gradient of PQ, I call it M1 because it's the tangent, I call it M1, right? So gradient of PQ equals to 1 minus 0, 2 minus 1 and a half. 1 minus 0, 2 minus 1 half. So it's 1 over 0 0.5. 1 over 0 0.5 is 2. It means that the gradient of the line PQ is 2. But the line PQ is also the tangent to the curve. That means the tangent to the curve, the value is also 2. Okay, the tangent to the curve is also 2 because it's the same line. So knowing the gradient of tangent and knowing the point 2, right? Gradient at x equals to 2 is 2. So I use this pair of values, I substitute into the gradient function here. Okay, dy dx, I substitute with 2 because it's the gradient. Then the x here, I substitute with 2 because it is the x coordinate of the point. Here not? Sabar loh, sabar. Huh? Sabar. Any question?
Teacher, why dy dx right to?
dy dx again.
Right. Why dy dx right to?
Y dy dx right 2. Okay. Why the dy dx is 2 here? Huh? Correct. Okay.
Yeah.
Now dy dx is the gradient of tangent. Gradient of tangent. Now from the diagram here, can you look at the diagram here? Okay, from the diagram here, the gradient of tangent, I have another way of finding the gradient of tangent, not by using dy dx, but by using my knowledge of coordinate geometry. Because these two lines, these 2 points, they are known. The 2 points are known, so I can find the equation of the straight line joining these 2 points, P and Q. So using my knowledge of gradient, 1 minus 0, 2 minus half, then I will get the gradient of PQ. Gradient of PQ is the gradient of the blue line. Gradient of the blue line is the gradient of tangent. Oh, gradient of tangent is 2. So gradient of tangent is 2. I use the 2, I substitute into the dy dx. Then the x coordinate is 2. I also substitute into the gradient function here too. And any doubt? Ask again. Okay, right. Then I solve this equation. I can find the value of A. The value of A is 0.5. 0.5. Now this value of A, I substitute back into equation 1. Substitute back into equation 1. I can find the value of B. So B is 5. Okay. Now you try to make it a habit. After you have found the value of A and B, you substitute back into the original equation, replace all the values of A and B here. All the unknown values in the original equation. Don't leave it in terms of A and B. Leave it like this. Because you may need to use this equation in the following part. Okay, so once you have found the value of A and B, you don't leave the equation in terms of A and B here. You change it to something like this. Okay or not? Because you need to use it for the next part. Maybe lah, but whether use or no use, make it a habit. Rewrite the equation. Replace all the unknowns with the numbers that you have found. So far, okay or not?
Okay, teacher.
Okay, then we proceed to part B. Part B, the equation of normal at the point P, the coordinate of R. Okay, never mind. Concentrate on normal first. In order to find the equation of normal, you need to know two things. What are the two things? Gradient and a point on the normal. Okay, now the gradient of tangent you know is 2. What is the gradient of normal, which I call it M2? You take this number 2 here, terbalik, become 1 over 2. Negative sign, positive sign, you change to negative sign. That will be the gradient of number. Gradient of the tangent. Gradient of the normal. Now, knowing the gradient of normal, do you know a point on the normal? The normal is this green line. A point on the normal is 2, 1. So I use 2, 1. Gradient I use negative half. You think first, then ask.
So teacher, to find the equation of normal is use the formula y minus y1 equals to mx minus x1.
Yes. And any straight line you can use this formula, provided you
Only
know
for
the
because normal is the straight line. So we
normal.
use y minus
Yes.
y1.
Normal is a straight line, so we can use this. Okay.
Okay.
You must know a point on the line and the gradient of the line, then can. Okay, right. Then all these numbers you substitute inside, the gradient substitute here, the point 2, 1 you substitute in the x1, y1. and simplify this thing, you get y equals to negative half x plus 2. Or you can leave the equation of a straight line in any form. Y equals to mx plus c, or ax plus by plus c equals to 0, like this. Where is it? Just now we previously the last question. Okay, so you can leave it in any form you want, right? Then you want to find the coordinate of r. Now if you look at the diagram here, r is a point on the x-axis, and it is also a point on the normal. So you use the normal and the x-axis, you can find the coordinate of r. Now at r, the x-axis, y is 0. Y is 0. So I substitute y equals to 0 into the equation of normal because r lies on the normal. So I use the y equals to 0, substitute into the equation of normal. Then I found out x equals to 4. So x equals to 4, y equals to 0. So the point r is 4, 0. Any question about this point r? Now, this question is about coordinate geometry, right? Now, if they say on the x-axis, then the y is 0. If the point is on the y-axis, the x is 0. Terbalik. X-axis, y is 0. Y-axis, x is 0. Okay. Okay, now we're going to find the area of PQR. So PQR and all the coordinates of the 3 points you know. So you arrange them like this: 0, 4, 0, 2, 1, 1.50, 4, 0. So you can find the area of triangle. So just multiply and you find the area of triangle, right? Any question? These are only the first part is about dy dx. The later part all about coordinate geometry there. Okay. The last one. Okay. The application of differentiation to find the equation of tangent, right? Okay. Number 5. Okay. Tangent to the curve at the point 4, 3 intersect the x-axis at the point B. Find the distance AB. Okay, right. So I want to find the equation of tangent first, because if you cannot find the equation of tangent, you cannot find where it intersect the x-axis. Okay, so I differentiate this, bring down the half and become less by 1 become negative half, differentiate inside the square root, I get 2. Then simplify, the 2 cut away, and negative I bring to the bottom. So this is the dy dx. And they say dy dx at the point 4, 3, where the x is 4. So when x equals to 4, I try to find the dy dx. X equal to 4, find dy dx. Dy dx equals to 103, right? Okay, so I have found the gradient of tangent at the point x equals to 4. I know the gradient. I know the point is 4, 3. Can I find the equation of tangent? Yes, I can find the equation of tangent using this formula: y minus y1 equals to mx minus x1. So substituting 1/3 inside the gradient, 4, 3 inside the point, and you get this. This is the equation of tangent. This is the equation of tangent. This is the equation of tangent. Okay, so this is the equation of tangent. You substitute in the point and the gradient, you can find the equation of tangent. But they say this equation of tangent intersect the x-axis at point B. So this pink color equation, I want to know where it cut the x-axis. As I've said earlier, at the x-axis, what is 0? X-axis, what is 0? On the x-axis, what coordinate is 0?
Y.
X-axis, y coordinate is 0. If y-axis, x coordinate is 0. So I'm substituting y equal to 0 here. This one 0. So I get x equals to -5. So the point B must be -5, 0. This is the point B. Using the point B and the point A, right, I can find the distance between A and B using the formula square root of x2 minus x1 square plus y2 minus y1 square. Right? So this is the formula. So you can find the distance AB. Okay. Now the last part, the tangent to the curve is parallel to the normal to the curve at the point. Okay, so tangent to the curve, normal to this curve, they are parallel. So I try to find the tangent to this curve, I try to find the normal to this curve. Okay, so I find them separately. For the first equation, find tangent. For the second equation, find normal. Okay, so the first equation is this thing. Sorry. The first equation is this thing. Hx cubed plus kx plus 2. Now, since this equation lies on this point lies on this curve, I can substitute in this point, right, and form one equation. Okay, form one equation. Right. Then I proceed to find the dy dx from the same curve. Dy dx is 3hx squared plus k. Okay, so these two things I just skip first. Okay, I go according to the question. Okay, the question say like this, then I just do like that. Okay, the point and the tangent. Point, I substitute inside, form one equation. Tangent, I try to find the tangent, but uh, not not complete yet lah. Just the gradient function. I just find the gradient function. So now I look at the second curve. The second curve is y equals to x squared plus 6x plus 4. dy dx is 2x plus 6. Just differentiate. And they say at which point? Point -2, 4. Or -2. So I have to substitute in -2 here. -2 here. -2. And I found the gradient of tangent. But they say the gradient is parallel to the normal to this curve. So I cannot use this number 2 because this number 2 is the gradient of tangent, which is the m1, which is the m1. So I have to invert terbalik to find the gradient of normal. This is the gradient of normal. This normal, they say, is parallel to the tangent here at above. So I can use this number and substitute into the first equation now, right? The gradient of normal is the same as the gradient of tangent. This is the gradient of normal. It is the same as the gradient of tangent here. They are two different curves. Okay, so now gradient is 1/2. The point is 1, 2. I try to substitute into this gradient function here. Substitute into the gradient function. -half. I